Question 1 is a very typical double angle identity question. In fact, I give it a special name. I call these questions double triangle questions, because we are going to draw two triangles. And when reading them, they seem like, for math, that's a lot of words, and when I read it, it seems very complicated, but I'll tell you that students, once they get used to double triangle questions, like them because they're usually out of 3 or 4 marks, very predictable, and quite easy to do. Initially, though, it looks very scary. So given angle alpha in standard position, terminal arm quadrant 3, and cos alpha negative 3/5, angle beta standard position quadrant 2, and sine of beta 1/3, what is sine of alpha plus beta? Now, the first part of this is very similar to our triangle questions from chapter 6. And our triangle questions from chapter 6, our strategy was to draw a triangle. In the double triangle questions, we're going to draw two triangles. We're going to draw a triangle for alpha, and we're going to draw a triangle for beta. So the first one is talking about alpha, so I'm going to draw my quadrants here. It tells me alpha is in quadrant 3. So if I draw an angle in quadrant 3 and go back to my nearest x-axis, this would be my alpha reference angle. And I've drawn a right angle triangle for alpha. And I'm told that cos of alpha is negative 3/5. Well, if cos of alpha is negative 3/5, cos is adjacent over hypotenuse, that makes sense. This length is 3, this length is 5. Now, for me personally, I think and work with triangles and actually think of their distances. You might see some places online actually mark that that 3 as negative because it went to the left. Either way is fine. I always like to think about working with triangles and thinking of them as lengths, so I label them as positive, and I always use my cast rule in the end to figure out whether or not things are positive or negative. Very famous triangle. Do you know the other side by heart? It's the 3, 4, 5 triangle. Now, we already knew that cos of alpha was negative 3/5 from this triangle. You also know that sine of alpha, opposite over hypotenuse, will be 4/5, and it'll be negative because sine is negative in quadrant 3. Now, we're going to sort of split our page in half. So I'm going to leave some space on this side, and I'm going to draw my second triangle, my beta triangle below. And for my beta triangle, we're told that beta is in quadrant 2. So I draw an angle in quadrant 2. I can label my beta reference angle right there. And I'm told sine of beta, which is opposite over hypotenuse, is 1/3. A squared plus b squared equals c squared. The other side is the square root of 8. So I knew that sine of beta was 1/3. I now know that cos of beta, adjacent over hypotenuse, is root 8 over 3, and it will be negative because cos is negative in quadrant 2. So in a double angle triangle, the setup is very much like your triangle questions from chapter 6 that you've done already. You know what quadrant it is. They will always give you enough information for you to figure out what quadrant it's in. And then if they give you one, sine, cos, or tan, and you label your triangle, you can use a squared plus b squared equals c squared to find the other side. Then you can find everything else. Okay? So now we've drawn both of our triangles. The question was asking us to find sine alpha plus beta. And we go to our formula sheet, and this is equal to sine alpha cos beta plus cos alpha sine beta. So we have that formula. And the nice thing is that we have figured out all of this information from our two triangles. Now what's going to happen next is you have the information on the left-hand side. We are just going to now have to plug things in onto the right-hand side. But something fascinating happens here where I found out in the past there's a very common mistake that students make in this next step. And they make the mistake whether I show you the right way, like I could show you the right way to do it right now. If you are, it's like I think it must be a chromosome. Like you are genetically predisposed to either making this mistake or not. It doesn't matter if I show you the right way to do it. Some of you, the first time that you do it, you will make this mistake, okay? So I want you to do the first step right now, okay? I just want you to plug in the numbers. I'm going to come around and take statistics, and this chromosome is usually at about 50%. Usually I have a class where 50% naturally do it right the first time, and 50% naturally make a mistake the first time. And the idea that I found is that if you naturally make the mistake the first time, once you see your mistake, you're like, oh, and then you're less likely to make it again. There are some people that have this gene really strong and just like to make the mistake over and over and over again, but it's recessive, it goes away. The more times you make it and the more times you realize you make the mistake, it goes away. So I'll take statistics and we'll see the results. We have a very genetic strong class this year. 31.25% made a mistake, and 68.75 did it right the first time, so that's very promising. Okay? The mistake that is the most common mistake, I'll write it in red here because it is wrong, okay, is to do this. This is the most common mistake. So, and so on. Okay? Do you know what alpha is? No. We know what cos alpha is, but we don't know just the alpha. We don't know just the beta. So when you replace just the alpha with -4/5, that's the number one mistake. What do we know? And I'm going to erase it now. We know all of sine alpha. We know all of this. Sine alpha is -4/5. We know all of the cos beta is -√8/3. Plus sine there, we know all of the cos alpha is -3/5. There's no more sine, there's no more cos, and we know all of the sine beta is 1/3. So the number one mistake, and it's understandable because you're so used to putting in stuff for variables that you're very tempted just to plug in something for the variable. But we don't know alpha and we don't know beta. So this will be something you'll have to pay attention to when you, like, sometimes you're going to substitute in and you know alpha, and sometimes you're going to substitute in and you don't know alpha, but you know all of sine alpha or all of cos alpha. So in this case, I know all of sine alpha, I replace all of them. Once you get used to not making that mistake, drawing the two triangles in this question is pretty easy. Then just plugging things in, now that we know we just need to plug in the numbers because you know all of cos beta, all of sine alpha, and now it's just simplification. So this first fraction is going to be 4√8/15. The second fraction is going to be -3/15. We have a common denominator, so my final answer is 4√8 minus 3 all over 15. You could reduce the √8 to 2√2. It might be in a multiple choice question, but in grade 12, you can leave your answer with radicals, with square roots that aren't simplified. We do have to write our final answer as a single fraction. So had you left your answer as two fractions that need to be added, you're not done yet. We have to write our answer as a single fraction in the end. So questions for practice on this one are circle 8 and 13.